Welcome to this session of SCCA video tutorials by John and Tende. Today we're going to be looking at F5, which is performance management. It's one of the fun key papers in the skills section of your SCCA studies. We're going to be looking at some exam technique. We're going to be concentrating on a paper which was done in December 2010. This was SCCA December 2010. We're going to be focusing on question number 3. So if you don't have a copy of the question, I suggest you download it from the website, the SCCA website. I hope you all know what that is. For those who don't know, it is SCCA global.com, and get yourself a copy. You can download the answer as well. I can be reached at the following email address, john.ntende@gmail.com. So if you have some feedback, you need some more explanation, if you need some more material, just drop me an email and I will definitely respond to it. Okay, without wasting much time, quickly let's dive into the question. Question is number 3. So I suggest you spend like 5 minutes reading through the question to familiarize yourself with it. And before we proceed, you can pause the video and come back to read later. So the company we are looking at is called Cosmetico, as indicated in the question. But before we get into much detail, we need to understand the requirement. That is a key exam technique. You need to understand the requirement of any question. So if you read through requirement A, what we're trying to do is something called linear programming. Linear programming. I'll explain to you what that is, but I expect at this stage you have a fair idea of what linear programming is. The paper has 5 questions, each with 20 marks, which gives you your 100%. Each question is 20 marks, and you're expected to spend about 1.8 minutes. Now a quick computation will show that 20 marks by 1.8 gives you 36 minutes. So I wouldn't expect you to spend more than 36 minutes on this question. So if 36 minutes clocks, the best thing is to abandon this question and move on to another question. So to increase your chances of getting that 50%, make sure you attempt as many questions as possible. And the only way that you can do that is by being disciplined on time management. So once you know you're supposed to spend 36 minutes on this, make sure you work within that time limit. So the technique we're using is linear programming. So when you have a huge requirement like this, so you break down the question. 1, we've established the technique is linear programming. 2, we have to use the graph paper provided. So if you use anything other than graph paper, you're going to be in problems. Then 3, they've told us to calculate the optimum number of each product. Okay, and what we're trying to do is to maximize contribution. Then eventually we calculate the contribution per week. So huge question. You can see it looks scary, but we've broken it down. We're going to use graph paper. The technique is linear programming. We're trying to find the optimum number of each product. Our objective is to maximize contribution. And finally, we have to find that contribution, which at the optimum production point. Okay, is that clear? Before we proceed, you need to know the standard procedure for solving any linear programming question. So one is you define variables. So I'll clearly show you what they mean by defining variables. Okay. 2, you set what I'm going to call the objective function. 3, you establish what I'm going to call constraints. 4, you draw the graph, and they've told us to use graph paper, so don't do anything else other than drawing on graph paper. You determine what they call the feasible region. Finally, you determine what they call the optimal plan, what we're trying to do actually. So whenever you see anything linear programming, this is the standard approach you need to use. Okay. Define variables, establish your objective function, determine your constraints, draw the graph, determine the feasible region, and then finally draw the optimal plan. Okay. So we're going to go back to the question and try to read through as we are progressing with this question. So what are these variables? If you look at line 3, what we're trying, the requirement is to optimize the production. So what are the 2 key products? From here we know it is this thing here called cosmetic cream and lotion. So clearly our variables are the number of units of each of these products, the cream and the lotion. I hope that's clear. So the variables are the numbers of the individual units you're trying to make. Is that clear? I hope that's okay. So let's try and get into, so without even doing so much, I straight away define my variables, because I know the marks for each and every steps. So I call my x units of cream, okay, and then my y is the number of units of lotion. So by simply doing that, you already have some few marks. X and y have been defined. Okay. Then 2 we are going to establish our objective. Okay. If we go back to the question, from the requirements, if you recall, our objective is to maximize contribution. So let me just highlight this. You remember, we're trying to maximize contribution. So our contribution, just as a quick reminder, is equal to sales minus variable costs. Okay. So our contribution, which I'm going to call C, will be, if I'm making X units of cream and Y units of lotion, that means what I need is to find the contribution per unit for X and the contribution per unit for Y. If you read carefully through the question, this information has already been provided. And if you look at this last paragraph, you can see each unit of cream has a contribution of 9, and each unit of lotion or each bottle of lotion has a unit contribution of 8. So C is 9x plus 8y. So just this simple formula here is going to get you some marks. So by saying contribution is 9x plus 8y, those are some marks. Then 3 is constraints. Okay, so we need to identify the constraints. But what is a constraint? A constraint means the same thing as limiting factor. Basically, a limiting factor is something which prevents you from achieving your objective. So we're going to look through the question and try to identify what these limiting factors are. So back to the question, paragraph 2, okay? You can see that one of the constraints is that the supply of skilled labor, okay, is limited to 9,600. So our first constraint is skilled labor, which is limited to 9,600 minutes. Our next constraint, the purchasing manager is confident that they can obtain 5,000 grams of silk powder. So silk powder is in limited supply, so it is something which is preventing us from achieving our objectives, and is limited to 5,000 grams. They've mentioned that unskilled labor, you can see this line I'm highlighting, unskilled labor is unlimited. That means unskilled labor, we don't need to bother ourselves with unskilled labor because it is unlimited. We have a lot of it, okay? In this line here, we can see that this other ingredient called amino acids. So we have amino acids, which are limited to 1,600. Then, if you read carefully in the last paragraph here, they're telling us that the demand for lotion is limited to 2,000 units. So demand for lotion, which is limited to 2,000 units. And they've told us, if you clearly, all other ingredients are unlimited. So anything else, like here they've given us information on aloe vera. Clearly we've established that aloe vera is not a critical component, it is unlimited. Then we've been also told that unskilled labor is unlimited. So aloe vera and unskilled labor are not constraints for purposes of this question. So the next thing is we need to form equations to represent those constraints. Okay, so that's something very simple. I'll quickly show you. So the first thing we're looking at is skilled labor. So if we go back to the question, if you look at this section, which I'm just going to highlight here, okay, so they're telling us that skilled labor, okay, is limited to 9,600. So you can see that each unit of cream takes 4 minutes, and each unit of lotion takes 5 minutes. That means the total time in a period, okay, will be 4x, okay, plus 5y, okay, and this is should not exceed 9600. So 4x plus 5y is the total time. If you make x units of cream and you make y units of lotion, the total time you will take will be 4x plus 5y. But they've told us that total should not exceed 9600. So the equation you're looking for is 4x plus 5y, okay, should not exceed 9600. So this is what they call an inequality, okay, and we shall see how to draw this on the graph. So similar thing, I want you to pause the video and do the same thing for silk powder and get back after a short while. So please read through the question, do the same thing I've done for skilled labor, do it for silk powder and see if it makes sense. Okay, silk powder. If you look at the question, silk powder is right here. Okay, so each unit of cream takes 3 grams. So that means that is 3x. Okay, each unit of lotion, as you can see here, takes 2 grams. So that is 2y. But remember, this is limited to 5,000. So the inequality here should be less than or equal to 5,000. Pause the video, do the same thing for amino acids. So quickly, amino acids is right here. Cream takes 1 gram, so you have 1x, okay. Lotion takes 0.5 grams, so that is 0.5x. The amount of amino acids available is 16 grams, so the inequality is still less than or equal to 16. Lotion we know is y. They've told us it should not exceed 2000. So think about this. What is the inequality to use? Is it less than, greater than or equal than, or less than or equal than? They've told us that y, the number of units of lotion, is limited to 2000. So you cannot have a demand greater than 2000. So the correct option is less than or equal to. So this is clearly not applicable. So the inequality is y is less than or equal to 2000. So in most of these questions, there's also a final set of inequalities, which is called the non-negativity constraints. Meaning that x and y should be both greater than 0. So what this means is that I don't want to get negative units of cream. It doesn't make sense. And I also don't want to get negative units of y. It doesn't make sense. I want this to be real numbers, rational numbers. So I don't want to have a situation where I have negative values of x and y. Is that clear? So we finished with what we call the constraints. So what we're going to try and do right now is to move on to draw this graph. Okay, what we're going to try and do is to draw a graph. Okay, now this is where you really need to practice. I'm not going to use real graph paper, but I expect that when you go back, you actually practice this question using real graph paper. Okay, to draw the graph. So the first thing we need to do is draw two axes, a vertical axis and a horizontal axis. We shall let the vertical one be y and the horizontal one be x. So we need to draw the inequalities, okay, which are straight lines, and to draw a straight line we need only 2 points. Now briefly, we had the lines x, y should be greater than or equal to 0. Those are the easiest to draw, with this horizontal axis being the line y is equal to 0 and the vertical axis being the line x is equal to 0. Then we had the line y is less than or equal to 2000. That is a horizontal line going through y is equal to 2000. So this line here is y is equal to 2000. There were two other lines, rather three other lines, one for skilled labor, which was 4x plus 5y is less than or equal to 96. Now we need 2 points on this line, so what we do is we simply let one of the variables equal to 0, and when x is equal to 0 you can see that 5y is now equal to 96, dividing both sides by 5. Okay, you can see that y is equal to, quickly if we use the calculator, 96 divided by 5 gives you 1920. Okay, same thing when y is equal to 0, okay, x will equal to 96 divided by 4, which is equal to 96 divided by 4, which is equal to 24. Okay, so we're going to plot those points. So we have y is 1920 somewhere here, and x is 24 somewhere there. So if we join these two lines there, so this is the line for x plus 5y is equal to 96. Okay, the next line was silk powder. Silk powder, the equation was 3x plus 2y is less than or equal to 5000. So when x is 0, y will equal to 5000 divided by 2, which is 2500. Okay, and when y is equal to 0, x will be 5000, quickly, 5000 divided by 3, which is 1667. Okay, so let's try and draw these 2 points. So y is 25 is probably somewhere here. Okay, and x is 1667 is probably somewhere here. Okay, so when I join these 2 points, okay, so that is the line 3x plus 2y is equal to 5,000. So finally we have the line for amino acids. Now quickly pause the video and try and draw the line for amino acids. So amino acids. The line for amino acids was x plus 0.5 y is less than or equal to 1, 6. So when y is equal to 0, x is equal to 1, 6, and when x is 0, okay, y is equal to 1, 6 divided by 0.5, which should equal to 3.2. So 3.2 is somewhere here. Okay, and 1, 6 somewhere here. Okay, okay, so here is our line x plus 0.5 y is equal to 1,600. Okay, so the next step of this was to try and find the feasible region. Okay, so we're going to shade off the unwanted regions. Now the points on this side of this axis are all negative, so we are not interested. So I'm shading the unwanted part. So anything below this is unwanted as far as I'm concerned. Now we're told that y should not exceed 2000. So anything above this point, okay, I'm also not interested. So I'm shading off the unwanted part. Anything beyond this, I'm not interested. Now, for the remaining lines, similar approach. We're shading off the unwanted parts. So we're only interested in the less than or equal part. So anything this side here, okay, will represent greater than or equal to. So I'm not interested in anything to the right of all these lines. Okay, I'm not interested because anything beyond this will give you something greater than or equal to the constraint. So I've shaded off the unwanted region. So the unshaded part, which in this case is O, A, B, C, and D. So clearly the feasible region is O, A, B, C, and D. Okay, so one of the points O, A, B, C, and D is our optimum production plan. So the next step, what we're going to do is to try and find the optimum production plan. Okay, we're trying to establish which of these points will give us the best. Okay, so my note is a bit crowded, but let's see how we can progress. Okay, so what we want to do right now is to draw what they call an ISO contribution line. Okay, we're trying to establish what they call the ISO contribution line, and so our contribution C, okay, if you recall, our contribution C, just a second, our contribution C, okay, C, okay, was equal to 9x plus 8y. Okay, so to draw what they call the ISO contribution line, you let this figure equal to anything. You let this equal to anything. Now what we're going to do in our case is going to let it equal to any figure. Let's say 6,400. Now this is a random figure, okay? 6,400. So 9x plus 8y is equal to 6,400. So what I'm going to try and do is to draw this line within the graph. So similar approach. Let me write it down. When x is equal to 0, you can see I'm trying to do it in the bottom right hand corner. When x is equal to 0, 8y is equal to 6,400. Remember, 6,400 is any number. It's a random number. Okay, 6,400 is a random number which is divisible by both 9 and 8, the figures before x and y. So it could be anything. It could be 7,200, as long as the figure you get is divisible by the figures before x and before y. Okay, so in this case 8y is equal to 64. That means y is equal to 64 divided by 8. 64 divided by 8. Y is 800. And when y is equal to 0, same approach. X, okay, is 64 divided by 9. Okay, so 64 divided by 9, what do we get? 64 out of 9 is 7, about 7, 11. Okay, 7, 11. So remember, these are random figures. These are random figures I've used. Okay, The 6-4 is any figure which seems convenient to you, but it's better to use a figure which is both divisible by 8 and 9. Okay, so I'm going to try and plot these 2 points. So when y is 800, it's probably somewhere here. Remember, you must use graph paper. And when x is 711, probably somewhere here. So when you join these 2 points, that's what they call the iso contribution line. So you slide this point outwards, okay? You slide this point outwards, and the last point it touches is your feasible region, okay? So if we slide this outwards, my graph is not very accurate, but it is supposed to touch point B last. Okay, so what I'm doing is I'm sliding the iso contribution line, and it's ending up with point B, okay? Therefore point B, okay, point B is the optimum okay. So point B is the optimum point, okay? So point B is our optimum point. So if your graph is accurate at this point, read off the values for x and also the values for y, okay? So you read off, so that the figures read off at this point, and at this point will be the optimum points. But in this case, we're going to calculate what points B, okay, the corresponding value for x and y using what they call simultaneous equations. Okay, so you can pause the video right now and try to internalize what we've been looking at. Remember, this topic is very examinable. It has come up several times, and it is certain will come up once again. So what we're going to do is now to find, okay, so what we're going to do is now to solve okay. Now point B was the intersection of 2 lines. If you go back, if you rewind a bit, you can see it was the intersection of 2 lines. 4x plus 5y is equal to 96, and 3x plus 2y is equal to 5000. So the method I'm going to use is called elimination method, okay? I want to eliminate x, okay? So I multiply this equation by 4. Remember, the 4 is the one I'm bringing here, okay? Then I multiply this equation by 3. The 3 is what I'm bringing here, okay? So I multiply all figures to give you now 12x plus 5 by 3 is 15y is equal to 96 by 3. Quickly using a calculator, 96 by 3 gives you 28,800. For the second equation, we have 12x plus 8y. 5,000 by 4 gives you 20,000. Okay. So if this is my equation, let me call this equation 3 and equation 4. Equation 3 minus equation 4. Okay. 15 minus 8 gives you 7y. You can see that the x's disappear. Okay. Now 28,800 minus 20,000 gives you 8,800. Okay. Dividing both sides by 7 gives you y. Okay. Is equal to, so 8 divided by 8 divided by 7 gives you 1257.14. Okay. So I substitute for y in equation 3. Substitute for y in equation 3 gives you 12x plus 15 times 1257.14 is equal to 28,800. Okay. So if we solve for this equation, we have 12x plus 15 times 1257.14. So this gives you 18,800. Okay. 57.1 is equal to 28,800. So x, okay, will equal to 9942.9 which is equal to 828.58. So our optimum production plan is x is 828.58 and y, okay, is 1257.14. But we haven't yet completed the question. The question is telling us to, if we quickly go back to the requirement, calculate the total contribution per week for the new production plan. So the total contribution, okay, the total contribution C, remember, is equal to 9x, okay, plus 8y. So it is 9 by 828.58 plus 8y. Now our y was 1257.14, and this gives us Okay, so finally we've answered the question. Okay, the question was to find the optimum number. Okay, so the optimum number was y is 1257.14 and x is 828.58, and then they also told us to find the contribution. So the contribution is 17514.34. Okay guys, it has taken quite a while, but finally I think you get the grasp of it. So what we're going to do right now is to do part B. Now let's quickly go through part B. We're trying to find something called a shadow price. A shadow price. And then we're also trying to find something called slack. Okay. Slack. So let's see what these actually mean. So what is shadow price? Okay. So what is shadow? What is a shadow? Shadow price. So shadow price, we can define it as the premium over and above that a company is willing for one additional unit of a scarce resource. So it's the premium over and above the normal rate that a company is willing to pay for one additional unit of a scarce resource. Okay, so remember at the optimum point, okay, we had two lines. Okay, so they're telling us to find the shadow price for silk powder. Now you remember at the optimum point there were two lines. The first line was 4x plus 5y is equal to 9,600. I think you remember this was labor. Okay, so at point B, okay, the two lines were, and then the second line was 3x plus 2y is equal to 5,000. Okay, so this line here was silk powder. What this tells us is that at the optimum point B, okay, at the optimum point B, labor, okay, and silk powder are completely utilized. Okay, so if we make one additional unit, okay, one additional gram of silk available, what will happen to the new optimum point? So if we add an additional unit of silk powder, we end up with, okay, 5,001. Okay, so we have two equations. Okay, once again we're trying to solve these two equations simultaneously. If we eliminate x, so we have to multiply this equation by 3 and this equation by 4. Okay, we're going to end up with two equations, 12x, okay, plus 15y is equal to 28,800, and 12x plus 8y is equal to 20,004. Okay, so this is, let me call this equation 1 and equation 2. So once again, equation 1 minus equation 2, okay, we end up with 7y is equal to 8796, okay, meaning that y is equal to 1256.57. okay, so substitute for y in equation, let me use equation in equation 1. So we're going to have 12x plus 15 times 1256.57 is equal to 28,800. If you do the similar procedure used previously, you should end up with x is 829.29. okay, so you can pause the video and try and figure out if you can actually come up with x is equal to 829.29. So once we have that, we find the new contribution, okay, based on this new optimum production plan. So we find the new contribution based on the new optimum production plan. So C, remember, is 9x, so it will be 9 by 829.29 plus 8y, 8 times 1256.57, which gives us 17, okay, 516.17. okay, so the shadow price okay is the difference between the two contributions. Now remember the original contribution, if you pause and rewind, the original contribution was 17,514.34, the original contribution. So the difference is what they call the shadow price. So 17,516.17 minus 17,514.34, which gives you 1.83 per gram. So that is the shadow price. So what that means, that if the company wanted to buy an additional unit of silk powder, they will need to pay an additional 1.83 on top of the unit cost of silk, which is the unit cost of silk is 2.2. okay, so they will have to pay a total of 2.2 plus 1.83, which gives you 4.03. So if the company wished to buy, okay, more powder, they'll need to pay an additional 1.83, which gives you 4.03 per unit of gram. So that's what they mean by a shadow price. Okay, so quickly let's look at the final bit, which is something called slack. So we're almost there. Okay, we're going to try and see what slack is. Okay, So slack is the amount of unutilized resource at the optimum point. Okay, amount of unutilized resource at the optimum point is called slack. So the equation for amino acids, if you remember, was x plus 0.5y, okay, should be less than or equal to 1600. But remember, the optimum point, our x was 828.58 and y was equal to 1257.14. So I'm going to substitute these values, okay, into my equation here. I'm going to end up with 828.58 plus 0.5 times 1257.14, which gives you 1457.15. But remember, available, okay, they told us clear was 16, okay, so it is this figure here, okay. That means that the slack, okay, is 16 minus 1457.15. This is the figure here. So the slack is 142.85 grams. Okay, so we've come to the end of this tutorial. It's been a long one. Remember, you can give me some feedback, okay. Please give me some feedback on john.ntende, okay, at gmail.com, and I'll surely respond. Okay, wish you the best in the rest of your studies.